G'day, it's Clive Rocksinger here. Now, even though I'm showing a picture of an electronic device, this video mainly came about because I keep starting on projects and stop dead in the middle of them. And what stopped this one is that it was easy to get the shaft out, but by geez, it's hard to get back on. And what I have to do now is go to this new place in Horsham, I think it's called All Tools, and I've got to buy myself a press. I don't really have any way around it. I'm not going to get it done. I don't rely on anybody out in the bush. Always do it yourself. So I've got to save up for that, and it's probably going to be relatively expensive, probably $200 to $300. Get a 10 ton, or I probably need about a 5 or 10 ton. I did everything I could to get that through, but it just started bending everything, so I thought, no, I've got to buy a press. I don't have the equipment as yet to make one, but what that did do is it highlighted forces in frameworks, and I've got a program written for bending moment and beams, and I got some math and started working it out, and I thought, this has got no point of reference. And that's the trouble with this stuff every single time, is that when they give you a mechanical engineering model in theory, they have no point of reference. They'll give two boats. Oh, that's alright, all you have to do is just utilise vector mechanics with hydraulics in 3 dimensions with turbulence. So you're doing 3-dimensional calculus in vector mechanics. Yeah, easy, yeah, there's 35 years of engineering. Yeah, and of course you're starting to learn with this stuff. So what I needed was a model that would force an outcome but also checkable, and one that's totally mathematically complete. That can be totally calculated out backwards and forwards and inside and out with all sorts of math. So this is it here. And this is the best one I've built so far. This is a classic. The idea of this is some fucking arseholes next door talking. The idea is that I can put that on an angle. See the angle of the jack there. Oh, it's a radio. What I can do, what I have is there 2 angles there. You've got the angle of the piece of wood, but you've also got the angle of the jack. You've got 2 or 3 pivot points here. All of these are measurable. I can measure the leverage here from that point. I can measure the leverage on the end of it here and get a number. And also I can apply pressure to here and get a different number again. And also there's an angle there which can also be put on straight, and I can compare the two. And these gauges are more than good enough. The good thing about these type of gauges is that you can mathematically calculate the error. So what I do is I get an accurate pair of scale, I get a good little digital scale on there that's very, very accurate. I get an exact weight, and then I hang it off the end of this thing and compare the two numbers, and then use a multiplier, and you can get it just about dead on. So, you know, this in actual fact, I can actually, this is actually connected to the jack here is moving it up and down, and I can actually, hope I do this without dropping the darn thing. Well, no, I can't, because it's bolted in place. I've just shifted all of it. Anyway, I can measure the weights of those 2 points separately. That is actually connected to that. Now that's now disconnected from that. Anyway, this is a really good model. I'm going to get the vector math out and work out forces in frameworks, and then I'm going to apply it to this model, get some real numbers, and then calculate the whole lot and be able to start designing machines. That's what really needs to happen, and the level of math is going to be astronomical, but I'm already fundamentally, I've already been working with it. I already have my own trigonometry. I can calculate all of this out, and so this is the first time I've got a real model that's going to yield some really interesting results. I'm going to clean up, of course, and get it all nice and neat and tidy, and I'm going to have to bolt that frame down because it's a bit top heavy at the front. Anyway, Clive Rocksinger over and out.